Good morning. How are you all? Did you enjoy, raise your hand if you met somebody you hadn't met before in the first session. Me too. I met about 7 or 8 people, and I was really happy to have that time. So thanks to our organizers for making some time and space for us to get here late if we needed to, and also to really meet each other and get to know some of our institutes from across campus. So we're going to introduce ourselves. I'm Ray Levy. I'm the Executive Director of the Data Science Academy here at NC State and a Professor of Mathematics.
Hi, good morning. My name is Cranos Williams. I'm a professor in the Electrical and Computer Engineering Department, and I also serve as the Platform Director for the Data-Driven Plant Sciences Platform for the North Carolina Plant Sciences Initiative.
And good morning. I'm Alyson Wilson. I'm a professor of statistics and Associate Vice Chancellor for National Security and Special Research Initiatives in the Office of Research and Innovation.
So as I was walking around this morning, many of you are experts in your fields, and your fields are very closely related to data science and artificial intelligence. But I also met many people in this audience who said, I know some things, but I'm here really to learn. I'm really new. I'm really interested in what this new space might be like. I've heard about it. And so we really wanted to start with a conversation to lay some groundwork around what is artificial intelligence, what is some of the terminology that we hear flying around. So some of you will be familiar with everything that we say, and you can come argue with us about it afterwards. We'll have a great lunch. But for others of you who are really new, we wanted to make sure that as you're listening to the lightning talks and you're hearing some of this terminology, that you feel like you have some background in what is it that people are talking about, and can go find out more about some of these words.
And Ray, let me say, the other thing that I wanted to say is, at NC State, we work on really broad areas of artificial intelligence. There are people who are working on foundations and computation. There are people who are applying AI to solve lots of problems all across the university. There are people who are really interested in the societal implications of what's happening around AI. So that's another part of what we're hoping to do today, is to help you figure out sort of where across this continuum of all the work that we're doing does some of your work fit. And if you're working on applications and you say, well, if I could just figure out how to make this run a little faster, you might actually have a chance to meet that person who works in foundations who always says, if I just had an application to try my algorithm out on. And so that's another part of what we're hoping that we'll be able to do over these 2 days.
And you were talking a little bit the other day about common ground, how we might find some common ground here. Can you say a little bit more about that?
Absolutely. I think that what you have up here in terms of the experiences, in terms of the research, is pretty common in terms of what you would find out in the audience and in general. And the fact is that when you start talking about artificial intelligence, when you start talking about some of these other aspects, you don't have the level of common ground in some cases, that common terminology, the common understanding of what it means to be able to apply some of these algorithms. So I think that what we really would like to see is to get to a point where we have some sort of common language, a common level of understanding of what these things are.
So we're going to start with artificial intelligence. What does that mean? So Alyson, can you start us out with artificial?
Sure. So when we're talking about artificial, what we really mean is we are really talking about computers and machines. And so AI is not a new idea. AI really started getting some traction back in the 50s. But when we're thinking about AI and you're starting to think about why it's taking off, a lot of that growth is coming because of the improvements in machines, in computation, in storage, and a lot of those kinds of opportunities. So when you think AI, the first thing to think is computer.
And then intelligence.
I think for me, intelligence really boils down to decision making. How can you use information, use data, use observations to be able to make more informed decisions on a particular topic?
And has AI kind of changed over time, what we imagine it can do? I think Dr. Volk, mentioned a little bit the promise or the reality of AI.
Sure, I'll jump in. When you think about some of the AI from 70 years ago, I think there was initially an idea that the computer was going to really mimic what a human did. And I think that right now, if you're taking a look at what's happening in AI, that's much less emphasized than it used to be. I think what we're starting to see is a lot more emphasis on thinking about the humans and the machines as collaborators, as partners, as thinking about how do we let the machines do what the machines are good at, and how do we let the people do what the people are good at, and then how do you figure out how to let them engage and work as teammates?
All right, so that about covers AI. We're going to move on to the term data science. So I've been in many, many meetings this year where people have said to me, what is data science? And I think it's really important that we as a community of researchers find ways to talk about these terms and remember that if we can't talk to anybody about them, then our research will have less impact. So again, if we can now define artificial intelligence in a way most people can understand it, even if they're not all that interested. What about data science? So a lot of people have asked me, how are data science and AI related to each other? Are they the same thing? Is AI replacing data science? And so we had a little debate about it, and we came to an agreement amongst ourselves, I think. They may have changed their minds since last time I talked, so we're going to see. That data science is a big umbrella. And AI is one set of techniques and tools within that umbrella of data science. What do you think?
I tend to agree. I think that, at least for me, data science covers the entire gamut. So I said earlier, in terms of my interpretation, intelligence side of artificial intelligence comes down to decision making. But data science comes down to any type of interpretation of information. So whether that's visualization, whether that's computation, et cetera. So for me, data science covers all aspects of working with information, where artificial intelligence really focuses on trying to capture the essence of what are the underlying principles behind a decision, trying to mimic that in some way, and trying to basically automate that process effectively.
And okay, so we mostly agree. But as I introduced myself, I'm a statistician, and when I'm thinking about data science, when I'm thinking about AI, I'm also not just thinking about the decision, but maybe the original question that was asked. And so I tend to think about two different kinds of questions that I might ask about data. And the first one I tend to think about, I call descriptive questions. So when I'm looking at the data, what's going on in the data? Are there groups in the data? What is it that I can understand about the data itself? Descriptive kinds of things. The second kind goes by many different names. It's often called, technically for a statistician, we will call it an inferential question, but or a predictive question, or really just something where I'm coming in with a question and I want to use the data to help me answer that question. And so when I'm thinking about artificial intelligence, often I'm really thinking about in terms of what is the AI technique or method helping me do? Is it helping me describe what's happening in the data? Maybe it's helping me find clusters within the data. Or is it helping me do something inferential or predictive, helping me answer a question or look forward within the data? And so it's related to decision making, but for me it also gets back to fundamentally what am I trying to do with the data? And then because data really underlies everything, then I'm sort of linking back to the issues around data science.
Great, thanks to you both. So we hear AI and then we hear machine learning. Is it important to make a distinction between AI and machine learning? So I've been asking several people this over the last week. Is it important? And so what I've been hearing is there are individuals, perhaps in this room, who will say it's super important to make a distinction between AI and machine learning. But there will be others in the room who will say, that's a pretty fine distinction and there's a significant amount of overlap. And maybe that's because AI, artificial intelligence, ML, machine learning. Remember that artificial has to do with the machine. And so the artificial in artificial intelligence is associated with the machine and machine learning. And then the intelligence part, maybe that is like the learning part. And so again, artificial intelligence, machine learning. Machine learning, to me, even though maybe AI has been happening for a long time, to me, ML is a little bit of an older term. And the hotter, newer term seems to be AI. And I see people describing a lot of machine learning algorithms as AI because I think that's what you're seeing in calls for research proposals. You're not seeing as many calls for machine learning research proposals, right? You're seeing this broader umbrella of AI in the research proposals, and that's going to drive what language we use when we're proposing our research because we're going to be answering those calls. Anything you want to add to that?
That's a tough one. For me, there's a lot of context there, and a lot of terminology that is reused, used in different contexts, et cetera. At its basis, the way that I've understood it and the way that I've oftentimes communicated it to students, and again, there are going to be a lot of people in here that have worked in a wider array of aspects of this research area than I have. But for me, machine learning is any algorithm, any model that allows to make a decision, where that machine has a task to make a decision. So thus a linear regression, for me, is a machine. It's a machine learning approach, and you go through a process of having that machine learn something. So thus, machine learning can involve anything as simple as a linear description to something with a multiple layer convolutional neural network, which is extremely more complicated, extremely less tractable and understandable. So when you start to think in the realm of artificial intelligence, contextually, it tends to float more towards this higher level of complexity, whereas machine learning captures, again, for me, the entire gamut of how you train a machine to do something. Clustering, decision-making, regression, et cetera.
Okay, I think I'm going to make it worse before we make it better. Because when I think about AI and I think about machine learning, Cranos was really talking about algorithms and analysis, and I introduced these ideas of descriptive and predictive kinds of analysis. But when we're thinking about how you actually do AI, it's not all about the analysis. And I think a lot of people who work in the AI space really see themselves as working in a broader space. So let me talk to you a little bit about how we might broaden that space. So anything that we're doing in AI or machine learning requires data. And so when we're thinking about data, the first problem that we have is we actually have to generate data. So there's a whole lot of different research going on, everything from how do I build and deploy a sensor? How do I find, how do I discover data that already exists that might be relevant to my problem? So there's that whole question about data generation, and many people who work in AI and machine learning are very much on the data creation kind of piece. But then if you're going to create data, excuse me, you have to store it, right? And so, we're not talking about Excel spreadsheets anymore for most of the problems. We are talking about serious research, compute, and storage. There's a reason why OITA makes 2 terabytes of storage available to everyone, because the scale at which we are thinking about data has really fundamentally changed. So we think about how to generate data, then you have to think about how to store it in such a way that you can use it and you can find it. Okay, well, if you're going to store data, then that opens up some other problems. Then you have to be able to, when I was trained, nobody really taught me how to process something at a 2 terabyte scale. I was having a rough day if I had 1,000 observations, right? And yeah, Heike just laughed at me, right? So we are not at 1,000 observations anymore for many of these problems. And so that processing issue is a huge issue. And more than that, once you're storing data, then you have to worry about how do you manage it? How do you know if it's updated? How do you secure it? So, that's another huge piece of what we've got going on in this AI, machine learning, data science adjacent space. Then eventually you get to the point where you want to do some analysis, and we've been talking about that. But once you do analysis, if you're working at scale, there's a huge question about how do you communicate what you've figured out? And that often leads to questions about visualization. So what's the right picture? What do I use to communicate what I have learned from my terabytes or petabytes of data in a way that it's consumable? And then how do I interpret it? How do I get back to that question about decision making that Cranos was talking about? So, when we're talking about, is it data science, is it AI, is it machine learning? Sometimes it's a little broader. Are we talking about sensors or storage or cybersecurity or parallel computing or technical communication? All of those have something to say in this space that we're trying to describe today. So I think many of the folks who are interested in trying to learn about AI, you may not be somebody who's building a better compiler or building a better algorithm, but you may be the person who's helping us figure out what's the most effective way to store this information so that somebody can do analysis, or what's the most effective visualization I can create so that the analysis becomes useful and supports decisions. Okay, I'll get off my soapbox.
Oh, that's great. So I think what you just heard Alyson describe is a whole process of data science, from which data are we going to use, all the way to how are we going to manage it and store it, to what is the analysis that we're going to do, to how are we going to communicate it to the audience that we need to communicate it to, and then how even are we going to test it to make sure that what we're doing isn't biased in some way, that we cooked in unintentionally, or that we didn't recognize was happening, so that the decisions we're making are somehow reinforcing something we didn't mean to be perpetuating. So big umbrella of data science that has many, many components. This analysis part of the data is what we usually think of as AI. Maybe we also think about it as machine learning. And in machine learning, you start hearing about more terms. That learning term, you keep hearing in words like deep learning, supervised learning, unsupervised learning. And so these learning terms, sometimes you'll hear neural networks. I think you heard Cranos say neural networks. So these terms all have to do with how you're going about the analysis, and you may hear some of those terms in the lightning talks that we're going to hear today. And so just be aware that each of these things are things, if you are familiar with them, great. If you're not familiar with them, it's not a problem. You can just let that information come through the talks and start learning. What are some examples of unsupervised learning? Supervised and unsupervised learning has to do with how much you are interfering in some sense with the algorithm as it's doing its work, and making sure that what you're getting in the iterative process is what you want. Maybe you're going to supervise and interfere a little bit, or you're not going to. You're going to just let the machine work unsupervised. So there's some, again, that's not a technical definition, but it'll get you started in sort of understanding what people are saying when they say supervised or unsupervised. So what we want to do next is really move from this general conversation of what is data science and what is AI to why are you here? It's really important to us over this 2 days that everything we do relate to what you do, and that you leave here with new ideas about how you're going to do what you do, right? You're going to meet new people. You're going to be exposed to new techniques. You're going to know what the resources are around campus to get what you need and what your students need. But we also want, one of the nice things about going to a conference is you have time to reflect. So what we'd like you to do is take a couple of minutes. You can write this down or not, but I want you to think about, where is data science and AI playing in your work, and what do you want to get out of these next couple of days? What do you want to learn? Who do you want to meet? What do you want to think about? So I'm just going to give you a couple minutes individually to think about that. And by the way, I taught in a Quaker school for a long time. Americans are super, in generalization, uncomfortable with silence, but we're going to have some, okay? You're going to get some time to think. 2 minutes. It'll seem like forever. You can do it.
I was going to ask if somebody was going to play the Jeopardy music.
Yeah. Silence. That may be the only time you get 2 minutes of quiet in the next month. So I hope you enjoyed it. I hope you each have a goal for the conference, somebody you want to meet, something you want to learn, something you want to understand, question you're going to ask, or a conversation you want to have. So what do we do, Cranos, once we have those things in mind?
So I think that for the most part, what you would find, the things that you wrote down, you'll be able to recognize yourself as being in, 1 in 3 possible areas, maybe more. So someone that is possibly more on the foundational side, someone like Alyson mentioned, really focuses on algorithm development, algorithm improvement, algorithm implementation. Someone that's more on the application side, someone that, recognizes aspects of artificial intelligence, machine learning, recognizes its uses, have used it in the past, or would like to use it in the future. Or someone that is AI adjacent. So someone who hears all of these different terms, hears things like ChatGPT, wonders, what it means, what does it mean for my kids in terms of how they learn, what does it mean for my students in my classroom, et cetera. So I think once you're able to kind of recognize this aspect, trying to then identify how to relate to others, how to communicate to others, how to communicate the things that you're looking for and the things that you need in terms of identifying collaborations, learning more, et cetera. I've faced this many times over in my area of work, which tends to be more translational on the agriculture side. And you have people like myself who are doing research in this space, and then you have stakeholders, farmers, producers, that see the potential benefits, but really struggle with being able to decipher all of the terminology, all of these nuances that will help them to understand whether or not AI can actually have some level of benefit to them. And then you have the researcher, someone who has lots of information, lots of data, and can get access to almost any package where you can train a neural network. All you got to do is structure the data properly, send it into this thing, and something comes out. But like Dr. Volk mentioned earlier, how do you interpret it? How do you understand whether or not this actually makes sense? How do I even know that the data that I collected fundamentally helps me to address the question that I'm actually going after? This is where connecting with all of these different individuals become extremely important, because then someone that's more on the foundational side can really help to provide that insight. Or for somebody that's on the foundational side, can actually see how their algorithms can be used in applications beyond what they even thought of. So I think that's kind of where we go next, using this common language, this common vernacular, to then identify how you can communicate with others.
Okay, so what we thought we would do, just as a little bit of a preview for some of the talks that you're going to see at noon today, is we thought we would just give a few short examples to help sort of orient you towards some of, the breadth of what we see as the different areas where you might be working in and around AI, machine learning. And so I'm going to start talking a little bit about methods and foundations. And so a lot of times when people start talking about AI, I think they may sort of have in their brain this space. This is a space often of computational and mathematical researchers. Not always, but these are folks whose fundamental work is in developing algorithms. But it's a little broader than that. It's not just algorithms, it's also developing hardware, developing computers that can help you execute things. It's folks who build a better compiler so that you can execute things much more quickly. So when you're thinking about people whose work is in the hardware space, in the software space, in the algorithm space, that's really sort of what we have in mind about methods and foundations. But I'm going to take that just a little bit broader, because I think some of the methods and foundation works also bleeds over into the data side of things. And so in particular, I often think about, these are often called the V's of data. So as we've talked about, data's big and getting bigger. So folks who are helping you figure out how to work with very large data sets, often that's very foundational and can work broadly across a large range of problems. Or figuring out how to work with streaming data, or figuring out how to work with very heterogeneous data types. So, when we were designing an experiment and we would go out and we would collect our 30 data points to answer our question, that data was really all the same. But now maybe I'm working with text and geospatial data and video data, and we have to figure out how to think about the fusion of all of that data. These are the kinds of things that when we're kind of, describing a bucket of some of the work, we tend to think about more in methods and foundations.
I mean, in terms of some of the examples that I've come across in terms of my work and my research, I think it ranges from the foundational to the more translational and applied. Foundational would be something like tracking gene expression over time and space. So you have images, let's say confocal images, which basically captures fluorescence. Basically, it's an image. And you are trying to address and answer fundamental questions about cellular activity at the basic level. So where AI, machine learning, et cetera, can really come into play is being able to actually segment, identify, and track these aspects. Tracking things like root growth in an automated way, tracking direction of root growth in an automated way. These are, again, other fundamental areas that we've worked on. I think there's also some other more translational aspects, things where information can be extracted and provided to potential stakeholders. We have projects where, for example, we're looking at streaming data, streaming images, where we are basically segmenting sweet potatoes across a packing facility. And this thing is producing, running really hundreds of thousands an hour of sweet potatoes running through this facility. And no one is gonna go in there and count those things by hand. No one is even gonna be able to see half of those things. But using things like AI, we can not only quantify them, but we can actually assess things like shape and size, dimensions, length, width, all of these things that a stakeholder really takes for granted. And if you're able to just do that and extract that kind of information and provide it to them in a chart, just to show them the type of inventory that they have, it helps them to make better decisions in terms of planning, packing, forecasting orders, et cetera. So those are things that, again, are somewhat straightforward, but the type of information that can actually be extracted can become extremely important to a specific individual. So these are some of the examples where we've actually seen AI become very helpful.
Great, and so my work has been in industry across a lot of different kinds of applications. So each year I would have a student team, we would work for a different industrial sponsor for a year, and it was interesting to work in the space of a decade when the way we were approaching problems really changed. So an early problem that we had was for an IV drip company that made IV pumps, and they were concerned about infusions when the IV, maybe the arm is under a cover and the IV hasn't gone into the right place and the fluid isn't going in the right place, and if this happens to a child, they may lose their arm. So these are very serious, they happen often, and the question was, our sensors in the pumps are not giving a signature that would set off an alarm, that would tell somebody to go look. For some reason, the usual ways that we have of seeing that something is going wrong are not showing up. So could you look at the data that we can get from our pumps and decide, could these data predict an infusion, or are we going to have to put some other kind of sensor in our pumps, which would be extremely expensive, right, with all of the ways that you have to go with a new medical device. We really don't want to do that. So we really want you to find what the signature might be using the pumps that we had. And so our students, the big question the first year we looked at this project was, well, we're in math and physics. Should we use an ordinary differential equation model or a partial differential equation model, right? And a lot of times in those early years, these were and these kinds of physics-based or mathematics-based models are still very valuable. But they were really all that we were doing to look at the problems in those days. That's what we had to work with. So fast forward a little bit, we had a problem for a satellite company. It was very cool to get to go look at the real satellites. And the question was, we have a way of using very standard control theory, linear control theory, to make sure that the satellite orientation is good. If the satellite is off by a fraction of a degree, someone's going to lose their internet, their television, be very angry. So what do? We want to have, fancier ways or better ways of dealing with satellite orientation. Here are the kind of problems that we encounter, but we're also very risk averse, right? We don't want to change what we're doing. And so they knew that there were nonlinear control theory problems around, but they weren't sure that they could move to them very easily. So again, the team of students found a really wonderful master's paper that used a combination of linear and nonlinear theory, where the linear was sort of double checking the nonlinear control theory, but it's still very classical models, right? Things that have been taught for many, many years. So fast forward again, all of a sudden, every problem we got started looking like anomaly detection. So for example, we worked for, I think I can say this, Microsoft Bing, and they wanted to understand how their internet traffic was, whether it was normal or abnormal in their search engine. And so if sometimes abnormal looks like it's the Super Bowl, and everybody's acting differently than usual, but there's nothing wrong. It's supposed to be happening. And other times they're getting signals that look like they need to wake somebody up and fix something. And so again, they gave our students all of their internet traffic data and asked, can you detect anomalies? And they knew of some anomalies in that data, but they wanted our students to go find them. All of a sudden, they're using machine learning models, right, and trying different models that are out there to see which ones might do the anomaly detection. And then many, many problems. Again, we were hired by another company that was doing some drilling, and they wanted to know, can we drill faster and safer? And can we do that in a way using the signals that are coming in from our sensors? And again, can you detect anomalies that would indicate we need to slow down or that something unsafe is happening? So all of our problems turned into anomaly detection models. These days, I don't hear the problems from industry being couched in that same way. You heard Alyson talk about data integration across different sources. And I think right now what you're hearing from industry a lot is we're getting data from here, we're getting data from there. And it could be the same kinds of data from different parts of their company. It could be a company that has many companies and they're getting data from across the company. Could, like Alyson said, be different types of data. And so again, the big question is, how do we integrate these types of data to get more insight when maybe they're inconsistent, maybe they weren't collected the same way? And in healthcare data, same issue, right? You have many different doctors. How many of us have more than one patient portal, right, from our different doctors with our different data? And I think in the next few years, you're really going to see a big industry of how do you integrate your own data from across all of your experiences and your Fitbit or whatever devices you use to track your exercise and your food, to try to inform personalized medicine. So it's been super interesting to see this shift. And so, we've been asked to predict, what's gonna happen 50 years from now, right, in AI? What's gonna happen 50 years from now in data science? And it's super hard because I can say that just in the last 5 years, the kinds of questions that we're asking, the ways that we can manage and store data, and the tools that we're using are rapidly changing.
And so something that I think is interesting, if you asked all of us would say we work on AI. And if you're listening to the kinds of problems that we were just talking about, they cover a huge range. And again, we've sort of set up just some initial ways to think about this, which is, in terms of foundations, in terms of applications. The one area that the three of us didn't talk about right here is really in the broader societal impacts around ethics, around privacy, around bias. And we've actually, because that is so important and moving so rapidly, tomorrow at 1 o'clock, we will have a panel where we actually spend the entire hour with a group of researchers from NC State and outside too, with a group of folks, and Ray will moderate that panel, really digging in more depth to some of those issues. But the other thing that I'll mention is the thing that we will be doing today at noon is we have 4 speakers from across NC State. And we tried very intentionally to get speakers who work on AI from many different perspectives here at the university. And they'll have a longer time than we just took, but they'll each have a chance to really set up their research question and the approach. And again, part of that is we do want to really open the aperture so that the university can see all the different places where AI and machine learning are impacting the work that we are doing here at the university.
Great. So could we have a time check, Laura? And we have how many minutes?
About till 11.
We have 6 minutes? Okay, great. So the last thing we want you to do, remember you had that individual time to think about why you're here, who you want to meet, what your goal is. we'd like you to turn to one other person and share something that you're excited about, or something that you're concerned about, or something that you're planning to do next over the next 2 days and in the future. So we'll give you a couple minutes to do that, and then we'll wrap up. All right, we're going to wrap up our conversations. I'll give you a couple seconds. Thanks for talking to each other. All right, I love it that you're still talking. I'm going to wrap us up with this idea of why is AI so hot right now? Like, why is everybody talking about it? Is it just ChatGPT? Is it just large language models? Are there other things? You know, I think we really think that part of what's happening is that sensors are accessible to everyone. We carry them around in our phones. Our data are exploding. I think people are recognizing that they want insight from their data. And so these tools are really promising a possibility of being able to manage the large amounts of data that we're all swimming in right now. And our hope is that at NC State, we really think about collectively how we engage in research and how we think about all of the ethical and human as well as environmental considerations that go around with our decision making around AI.
And I think one of the things that with AI, data science, data analytics being such hot topics, one of the things that we always have to remember is that artificial intelligence is a GIGO system. GIGO meaning garbage in, garbage out. If you do not put good information in there, you're not going to get good information out. If you don't structure your problem effectively, you're not going to get the types of results and answers that you're trying to get. So in really trying to address and integrate some of these things into our research, because they are hot topics in RFPs, it becomes very important to understand exactly how to try to integrate these things. And that means, going back to what we said earlier, communicating. communicating across different individuals with varying levels of expertise so that we can really understand what types of tools are best for the problems that we have.
And so with that, we are going to wrap up this opening session. Our keynote fireside chat is going to start in just a minute as soon as Dr. Srivastava joins us. So while we are waiting for him, you guys are going to get a minute or two, grab another cup of coffee, and come back. What we really want to do in this next talk is we spent the last hour or so sort of thinking about NC State and thinking about where we as people at NC State fit into this ecosystem. What we're going to do now for the next hour is really open that aperture again. And it looks like Ashok is joining us. And so we are going to transition and have a conversation with Dr. Ashok Srivastava, who is the Chief Data Officer and Senior Vice President from Intuit. So I'm going to give everybody just a second while we transition. I'm going to let you transition, and then I'll be back in just a minute, and we'll kick off with the introduction, and we'll get started with our conversation with Dr.
And thank
Srivastava.
my colleagues, please, for this fabulous conversation.